Okay, so let's get started. This is section 3.2. Remember in 3.1 we had the measure of central tendency. So we have seen there about mean, median, mode. Now here we are going to look at the measures of variations. That means we are going to look at how far the data values are scattered or distributed, right, from the mean. So this is called the measure of variation. Okay, so before going to do that, so let's look at the first definition, which is about range. So we all have seen this range, right? So range is nothing but, the difference between the highest and the lowest values. Therefore, the range is given in notation wise. The range is given by h minus l. H is the highest value of the data set, and l is the lowest value, right? Okay, so now this is the most important part in this section we are going to look at. This is about the population variance and the standard deviation. Remember last time I explained you about the population, right? Suppose if you consider all the data set values, right? Say suppose if you are given big N of data values, right? So from the sample, remember um, we pick on the few of your population data values, right? Say suppose if you have only a little n of them, okay. So last time we had the sample mean is given by x bar, right? We have the formula for that, so you can check your notes, right? But for the population mean, we use for the population mean we use the different notation, right? Which is called mu. It pronounced like a mu. This is one of the Greek letters. So mu stands for the mean, but for the population mean. So again, this is an average. Therefore, you are adding all the data values. But now you are dividing by how many data values I have in the population. That is n of them, right? Right. So the number of data values here under the population is say big N. So here the number of data values under sample say little n. Therefore, the population mean mu is given by add all the data values divide by what? N. In other words, you are adding all the data values x1, x2, all the way up to x of big N, because these are the data values I have here under the population. So you need to divide this or the number of data values under the population, which is N. Okay. Whereas we had this formula last time, the sample mean is given by x bar, which is simply you are adding all the data values under the sample. Sample I have only up to little n of n, so you need to divide by little n. Okay, no confusion. So the notation is now mu and x bar for me. But for the population variance is one kind of another measure, right? So the variance for the population is simply given by the notation wise we use like this. This is called sigma, but this is sigma, but the lowercase letter of the Greek. Remember last time we had the summation also sigma. We used that notation for the uppercase. Okay, no confusion. So uppercase sigma for the summation, lowercase sigma for this. Uh, we use this for the square, this sample. Sorry, the population variance. Okay, the population variance sigma squared is given by what? The summation of what? The difference between your data value and the this mu, the population mean, then square, then find this value for each data value, then add them, you will get the summation. Then you need to divide by what? The population size, the data values. There are n of them. So this is the formula we use for the population variance. Okay. So in other words, if you want to find the population variance sigma squared, first of all, you should find, the population mean mu. How do you find that mu? Simply add all the data values, divide by number of data. Once you have mu, simplify this expression by plugging those, that mu value here and find this guy for each data value. Okay, I will explain one example, then you understand. So that is the formula here. So look at that. X stands for the individual data values. This means so x1, x2, and so on up to xn. Okay. So that is there. Now, how do you find the population standard deviation? The standard deviation is nothing but the standard deviation. I will use hereafter standard dev for standard deviation. Standard deviation is nothing but simply the square root of your variance answer. Remember, for the variance we use sigma squared, right? Therefore, if we take the square root of sigma squared, that is simply just as the sigma. So if you are asked to find the standard deviation, first find the variance of the problem sigma squared, then take the square root. So we use sigma, little sigma for the standard deviation. Okay, so little sigma for standard deviation and little sigma squared for the variance, right? In formula wise, this is nothing but the square root of your variance formula. Variance formula is here, I already have, right? This is my variance formula. Then divide by n. So this is, the formula we use for standard deviation. So many new, notations you see here in this statistics course. So uh, we need to get familiar about these, the notations first. Okay. So that is there. So let's do this problem. Find the variance and the standard deviation for the data set. Okay. Okay. So I'm going to find, right, the variance and the standard deviation. So I'm going to use the formula for the variance formula. So variance we use sigma squared. That is, what is that formula? The summation x minus mu squared over n, right? So first of all, we will find mu. What is mu? Mu is nothing but you could consider this as the population, right? So, because we are doing problem on the population, standard deviation and variance. So I consider this as population. You may have sample also here, but in this case, I'm considering this as the population set. Okay. Therefore, I'm finding the population mu, right, which is given by the formula says that simply you add all the data values, then divide by the number of data values. If you look at this problem, how many data values are given? 1, 2, 3, 4, 5, 6. So I'm using big N because this is the population. So I'm simply adding all the data values 10 plus 60 plus 50 plus 30 plus 40 plus 20, then this all divide by number of data values, which is 6, right? Okay, so find that number. So if you find, take your calculator and simplify, so it is 35. Okay, therefore the mean for this problem is 35. Once you have mean answer, now I'm going to calculate the variance. Okay, how are you going to calculate? I'm using this formula. So this is kind of, now you see, now you have to find this expression for each data value. This x denote here what? Each data value. So first I'm considering my first data value, x1 is 10. Therefore my first, this is 10. Then subtract the mu answer we got 35. Okay. But after getting this answer you have to square. So this is basically the first term of this summation, right? Remember, I have the summation notation, so you have to keep on adding. I'm taking my second data value, which is 60. That is my second x. Then subtract again mu. Mu is fixed for this problem, which is 35. Then square. Plus my third data value is 50. Then subtract again mu, which is 35. Then square. and so on. You do for all six. So now next, this is 50. The next 30, subtract 35, then square. Then the next one, 40, subtract 35, then square. And the last data value is 20, subtract 35, and square. Then this is my the summation, right? Now we have divide this all by what? By n. The sample size, sorry, the data values, the number of data values is 6 now. Therefore, you need to divide by 6. Now take your calculator. So you put type this all together, put the parentheses there, then divide by 6. Okay. So find the answer of this. Okay, so use the calculator and find this answer. So I got my numerator. If you type this all in your calculator, I got 1750. Why don't you check that? So divide by 6. Okay, so what is that? So 1750 divided by 6. 1750 divided by 6. So which is 291 point. So that is my variance for this problem. Okay, this variance. But they are asking us to find the standard deviation also. Remember, the standard deviation is given by simply little sigma, that is square root of your variance answer. Yes, I got the variance answer for first part is here. I got 291.7. Simply find the square root of that. So let us find that. So second square root of 291.7. Okay, so it is 17.1 for the one decimal place. So which is 17.1. So that is my standard deviation. Yeah, this is my variance. That's it. Okay. So this is all about finding population standard deviation and population variance. Okay, now let's move to the sample variance and the sample standard deviation. For formula for the sample variance, okay, for sample variance we use little s squared. Okay, so the sample variance is given by kind of similar to the population variance formula, but instead of mu, we use now x bar. Remember, x bar is nothing but the sample mean, right? Because since we are considering the sample, you need to find the sample mean, right? But what is here now? Now you see the denominator says n minus 1. This little n is the number of data values in your sample, then subtract 1. So this formula is slightly, different than your population variance formula. Your population variance formula had denominator is n, right? But now instead of n, you have n minus 1. So make sure that um, you know you use the correct formula. Okay. Right. So this is the formula we use for the sample variance. Suppose if you have the sample variance answer, now we know how to find this sample standard deviation like there with each. So simply take the square root of this answer to find this sample standard deviation. So we use little s. Okay. So in summary, let me write down here. For the population, okay, the variance is given by sigma squared. Okay, the formula is x minus mu squared over big N. But for the standard deviation under the population is we use what notation? We use sigma. It is simply the square root of your variance answer. Okay. But for the sample variance is given by little s squared. That is the summation of the data value subtract x bar sample mean then square, but you need to divide by little n minus 1. This is number of data values from your sample. Okay. Since you have variance answer for the sample, then the standard deviation for the sample is given by simply just s. That is simply the square root of your. Okay, so now let's look at this example. The number of public school teachers strikes in Pennsylvania for a random sample. You see now, they are talking about the sample. Therefore, this problem is about finding sample variance and the sample standard deviation. Okay. Okay. So let us do this problem. So let me write down the formula. The sample variance. Now I'm going to use a squared formula, which is the summation of what? X minus x bar squared over n minus 1. Remember, little n, the number of sample size or the data values are 1, 2, 3, 4, 5, 6. There are 6 data values, right? Then you need to find the first x bar, right? What is x bar? Sample mean. We have the formula for the sample mean, right? Simply add all the data values, then divide by number of data values. Okay, I'm just simply adding. Then divide by 6. So find this answer to one decimal place. So find this answer to one decimal place. Okay, so I got here 51. So why don't you check my answer over 6? So that is 8.5, right? So that is sample mean I got. I need this answer to find the sample variance. Okay, that is a square is given by. I'm going to find one by one this value. So the first data value is 9, right? Subtract x bar, which is 8.5. I have the parenthesis, yes, then square. So this is my first term of the summation, right? So then plus my second term is 10. Then again subtract x bar, 8.5 squared plus 14 subtract 8.5 squared. So I don't have space here, so I'm writing down plus next one 7 minus 8.5 all things squared and plus 8 minus 8.5 all things squared plus 3 minus 8.5 all things squared. Okay, so these all my summation expression, the numerator of this fraction. Then this all you need to divide by n minus 1. Oh, my n is now 6. There are 6 data values. Then divide by 1. Okay. Now take your calculator, carefully type this all with the parentheses, set of parentheses outside. And I got this as if you type this all numerator first type the numerator. Then I got 65.5. Why don't you check with my eyes? Then 6 minus 1 is 5 in the denominator. So if you simplify this, that is 13.1. Okay, so that is my variance for this problem. Once you have variance answer, finding standard deviation is always easy. So the standard deviation is simply the square root of your variance answer, right? My variance answer I got 13.1. So find the square root of 13.1. Okay, so what is that? So let me find out that. So square root of 13.1. Okay, so that is 3.6. That is my sample standard deviation for this problem. If you want, you could use the notation little s for your answer. This is little s squared. So this is sort of easy, no? Okay, so this is the way to find the population mean, standard deviation, sample mean, and sample standard deviation. Now I'm going to show you how to use the calculator to find these values. Okay, I'm starting with here. Okay, so let us do this problem first. Okay, so I'm going to use the calculator to do your first example. Okay, so I'm going to write down something here. So I'm going to use the calculator. Okay, so enter all the data values. So data sets, enter all the data sets into where? Into L1. Okay, then that's it. Then we go to stats, then calc. Like we found, the sample being same procedure. Then go to calc and find one word stats. Okay, so then enter. So if you do that, so let me show that here. So go to stat, edit. So let me clear these. Okay, so I'm entering all the values 10, 60, 50, 30, 40, and 20. Okay, then I'm again go to stat and the calc and the number one and enter. You got bunch of numbers here. Remember X bar for the sample mean, but remember we are finding what? We are finding the population variance. Which notation here for the population variance? You see now, you don't find the population variance. Instead, you see here the population standard deviation sigma x. So in your calculator, let me write down some things here. Sigma x in your calculator. This means this is population standard deviation. Okay. Once you know the population standard deviation, then how do you find the population variance? Easy. Simply take the square of this answer. So the population variance is simply look at your calculator, find that answer, then square them. Okay. Since you have bunch of the simples here, so I'm choosing the second one. You see now Sx in calculator. S means that is your sample standard deviation. Okay. So make sure that you understand the notation, correctly in your calculator. This problem is about finding the population variance and the standard deviation. Therefore, I'm looking for what? I'm looking for sigma x. So if you look at sigma in your answer, you got 17.1 as one decimal place. So that is your standard deviation for the population. Yes, 17.1 we got here, you see. Therefore, it is coming correctly. Once you know the population standard deviation, square them to find the population variance. So population variance simply the 17.1 square. So what is that? Find out that value 17.1 square. That is 292.4. Yeah, that is the answer. Oh, it is slight difference between your the manual doing and the calculator. It doesn't matter. So I'm writing 292.4. Okay. So you see now the calculator population variance is 292.4, but the manual way we did and we got 291.2. It doesn't matter. You could write either answer in your work. Okay. So that is the way to find um, population standard deviation and the sample standard deviation by using the calculator. So I'm leaving you this one for you guys to practice. Okay, so why don't you practice this? Okay, using the calculator, do this problem, this example. Okay, so you need to find what? You need to find the sample variance Sx. Find this answer. After that, you need to find Sx squared. These two you need to find. So this is my standard deviation answer, sample standard deviation. This is the sample variance. Okay, find these two. That is your work. You should get very close to these two answers. Sorry, Mm, this and this. Right? Okay, now let's move to the next one. Okay, what is this? Shortcut or computational formula for a square then S. Hmm. This is, the difference way of for finding sample variance and the sample, the standard deviation. So this formula is slightly different than the previous formula, the sample the previous formula. This is the previous formula we used. What is the difference between this formula, these two formulas and this one? If you look at this formula carefully, you don't see x bar here. That means what? This formula is, kind of a shortcut formula. Here, remember, when you use this formula, first of all, we found x bar, right? You see, first we found x bar. So we have additional work, extra work if you want to use this formula because you have to find x bar before going to find s squared, right? But this formula says you see nothing about x bar. So you don't need to find x bar if you use this formula. Only thing is you have to use the data values, data set. So x stand for your data values, right? So first find the square of your data values, then add them, then add the data values, then find the square. Okay, so I will show you how to use this formula. So I'm going to use now, uh, this formula, this shortcut formula to do this problem. If you want, you could use the calculator and check your answer whether correct or very close to your answer, whatever you got by doing manual, right? So the number of public school teachers strikes in Pennsylvania. Oh, this is the problem we did, right? The same formula, right? Same problem. I copied here. So I'm going to use these two formulas now to do this problem. So I'm going to find the variance s squared. I'm going to use now this formula, okay? What is that? Little n times summation of x squared, then the summation of x, then squared. These two are two different things. I will explain. Then divide by n times n minus 1, okay? So first of all, you need to find these two guys. So I will explain. So how do you find the summation of x squared? What is the meaning of this? I'm finding first this guy, okay? This means you are adding, you are summing all square of your data values, x stand for your data value, right? If you look at your data set, my first data value is 9, right? Square is, so the 9 squared, then sum all over the data values with the square. Second data value is 10, so 10 squared. The next one, 14 squared. Next one, 7 squared. Next one, 8 squared and 3 squared. So this is my summation of x squared. Check your calculator and simplify this guy. Let's look at that. So 9 squared plus 10 squared, 10 squared, okay, plus 14 squared, 14 squared, plus 7 squared, 7 squared, 8 squared, okay, then 3 squared. So I'm adding all the squares. So press enter. So you will get 499. Okay, this is 499. Now I'm finding the second guy, this one, right? Now this is different. This says what? First to find the summation of data value, then square. Here we squared, then you found the summation. Now first find the summation of the data value, then square. What does mean by that? That means first we have to find the summation of data value, just the data value, right? Okay, my first data value is 9. Just add them. 10, 14, 7, 8, and 3. Then square. You see now, these two things are different. You know, here squaring, adding, here adding, then square. Okay, let us find this answer. So 9 plus 10 plus 14 plus 7 plus 8 and plus 3, right? So then add up. Then this is 51, but I need to square that. So that is 51 square. What is that 51 square? 51 square, which is 260, 2601. Right? So I know these two numbers. What is little n here? Little n is the number of data values. 1, 2, 3, 4, 5, 6. This is 6. So you know all the numbers now. Simply plugging these three values into your formula, you will get S. Okay? Therefore, I'm using the formula S squared is n. N is now 6. So you have here multiple sign times. So 6 times summation x squared, which is 499, right? Then subtract summation x of squared, which is 2601. Then you have to divide this by n times n minus 1. My n is now 6 times 6 minus 1. Okay? So now type this all into a calculator and find the answer. Okay, let us type first the numerator. So which is 6 times 499 subtract 2601. Find this answer first. So which is 393. That is my numerator, this piece. Now this is 6 times 6 minus 1 is 5, right? 5 times 6, which is 30. Now 393 over 30. That is my sample variance. 393 over 30. 393 over 30. That is 13.1. What is the answer we got earlier? Yes, we got the correct answer. You see here, but here we use the different formula with the x bar, but this formula without x bar. Okay, either way, whatever you like, you could use. So since you have s squared, you know how to find s, right? That's so use the square root of your answer to find the s. Okay, very good. Okay, let's move to the next case. Suppose if you are given a grouped frequency distribution table, then how do you find the sample variance and the sample standard deviation? Well, you have two set of formulas here like earlier we had for the raw data set. So this is sort of a similar formula, we had, for these raw data, but now we have group frequency distribution. Therefore, I need to introduce, the frequency and the midpoints here. Okay, so you could use this formula to find the, the sample variance and the sample standard deviation, right? If here, if you look at the formula, what are they doing? They're finding the sum of the product of frequency with the square of the midpoint. XM stand for midpoint. We know how to find midpoint if you are given a data set, right? Okay, so little n, what is little n here? The total number of data values, which is in frequency table. This is nothing but the summation of frequency, okay? So use the table and find out. Once you have, a squared formula values, simply take the square root of that to get sample standard deviation, okay? So let's look at this problem. You are given a grouped frequency distribution table, okay? So now the question is what? Find the sample variance and the sample standard deviation for the frequency distribution data shown here, right? How many data values are there? There are 20 of them. That means if you add all the frequency column values, you should get 20, right? So we use, let me use the different color. So remember we use F for the frequency and XM for the midpoints. So they already found the midpoint. You don't need to do that part, right? They have given here. So we are creating some more, or two columns here. So you are given the frequency and the midpoint. So you know how to find the product. We did the similar problem last time. So just take the product of these two numbers. Simply multiply these two numbers and write it down. Okay. So take your calculator and multiply 1 times 8, which is 8, 2 times 13, which is 26, 3 times 18 should be 54, 5 times 23, it is how much? 115, right? Then 4 times 28, 4 times 8 is 32, 3 remaining, so it should be 112. And 3 times 33, which is 99, and 2 times 36, which is 38, which is 76. Okay. Now what is this column? This column says you need to multiply f with xm squared. Okay. So f is here 1 for the first class. So you need to multiply 1 with the midpoint square. Midpoint is 8, right? So 8 square. Find the answer. Next one, f is 2 times the midpoint is 13. So 2 times 13 square. Next one is 3 times 18 square. Next one is 5 times 23 square. And next one is 4 times 28 square. Next one, 3 times 33 square. And the last one is 2 times 38 square. Okay. Okay, so I got for this column. So why don't you check with my answer? So this should be 64, of course. And the next one is 338, right? 338. And the next one is 972. The next one is 26 of 45 and 31, 36, 32, 67, and the final one is 28, 88. Okay, so that is about f times xm squared column. So I need to find the sum of this column, right? That means I need to find the summation of f times xm squared. Simply add these values, right? Simply add these all. So I got this as 13,310. Please make sure that you are getting a correct answer. Then I need from this column, I need to find out the summation of the product of f and xm, right? Simply add this column data values, then you will get what? So if you do correctly, you should get 490. Okay. Now, if you look at this column, that is my frequency column. So if we add all the frequencies, this is nothing but my little n. That is 20. The number of total data values are given 20. Okay, I have all three numbers. Then I use the formula. So the sample standard deviation and variance formulas are there. So the sample variance is given by formula says that this is little n times the summation of f times xm squared, then subtract the summation of f times xm, then square this all over n times n minus 1, right? Sorry, this is the product. Okay, I'm simply plugging the values now. N is 20 times this guy, the summation of f times xm squared, that is here, right? 13,310. That is this. Okay. Then I'm subtracting, you know, the sum of f times xm, that is here, that is 490, but I need to put the square. This all over n is 20 times 20 minus 1. Now take your calculator and carefully type these values and find out. So I got my numerator answer as 26,100. Then the denominator, of course, 380. Then this should give you one decimal place answer as 68.7. Okay, so this is my sample variance for this group frequency distribution table. So once you have, the sample variance, therefore the standard deviation is sample standard deviation little s is simply the square root of your variance answer. The variance answer I got 68.7. Okay, so find this answer. So So that should be 8.3. Okay. Okay. Now I'm going to show you how to use the calculator for this grouped frequency distribution table. Okay. So what should you do? First, you need to enter all the midpoints into L1 and the frequency into L2. Okay, so once you input these two, it's going to be very easy. You remember that using calculator for this type of problem is very effective. You don't need to do this much hard work. Okay, simply you need to add two columns, midpoints and the frequency column. That's it. Calculator will find out everything for you. Okay, so let me show what those work now. So just I'm going to enter my all the, remember the order is very important. So you need to enter L1 into your midpoints, the data values, then the frequency, okay? So my L1 midpoints are given here, right? So midpoints here in the second column actually in your original table. So let me enter those values. So 8, 13, 18, 23, 28, 33, and 38. That is my L1 column, midpoints. Now move to L2. That is my frequency column. So first value is 1, 2, 3, 5, 4, 3, and 2. Okay? So after entering everything here, this is the catch. So go to stat, calc, right? Then choose one var stat, right? Then enter. Once you enter, it will ask you, you will get this display, okay? You will get this display. There you need to put the input, right? Calculator doesn't know how many columns you have, input the data values. So, I have two columns now, right? Therefore, you need to mention those two, L1, L2. Then press enter one more time. So follow this step. So you could use, this command to find, um, you know, the sample mean for the group, the frequency distribution I explained you in the previous section. So if you want, you could use this command there also, okay? But I saw there a different way, right? By looking at the product of, remember we did finding the product of f times xm into L3 column. I explained that method, different method in previous section. If you want, you could use the same command here, whatever I'm writing, to find the sample mean. Anyway, you are going to get bunch of all the uh, summary values for the given group frequency distribution table. Okay, so let us follow these. So if you look at your calculator, now I have entered all to the data values. That is this, So now go to stat one more time and calc. Then number one, enter. Okay, so you need to enter. Okay, you are here. So go to stat, calc, enter. Now you are here. Now you need to put the two input columns L1 and L2. I'm typing L1 here, second with 1, then put the comma, then L2, second with 2, then hit enter. You see now, you got the summary, right? So you have sample mean. So if you want to find the sample mean for the group frequency, you will get this answer. But remember now, we are finding what? We are finding sample standard deviation and variance. So sample standard deviation is Sx. So Sx will give you the answer, right? So the sample standard deviation, right? By using the calculator, you need to pick the notation Sx. Okay, so that is what. So I got that as Sx, one decimal point, 8.3. So that is going to be my sample standard deviation. What is the answer we got when you do manually? The sample standard deviation. Look at here. This is the sample standard deviation we got, right? Yes, 8.3. You see, but using calculator will reduce your workload. So it's very easy. So once you have the sample standard deviation, then it is easy to find the variance, right? The sample variance is simply Sx squared, that is 8.3 squared. So take your calculator and find the square of that. So 8.3 square, which is 68.9. So that is my sample variance. But when you do manually, you got 68.7. Doesn't matter because remember we found here standard deviation by manually by rounding up. So because of that, the rounding the numbers, you may have different values when you use the calculator and manual, but it's okay. So you could use either answer. Okay, so that is the way. Okay, now I believe you all are getting familiar with the calculator. Good. Okay, let's move to the next topic. This is about the coefficient of the variation. Coefficient of the variation is kind of a measure we use, to compare two different variable or data sets. Okay. So now the coefficient of variation can be found for sample or for population. So we have separate formulas for both of them. The coefficient of variation for your sample is simply given by the sample standard deviation divided by the sample mean. Okay, so this is simply C bar for sample, coefficient of the variation for the sample. Similarly, for the population, the coefficient of variance is given by the population standard deviation little sigma over population mean mu. Okay, so if you are asked to find the coefficient variance of the given data set, simply you find the standard deviation and mean, then divide them. Okay, look at this example. The mean of number of sales of cars over a 3-month period is 37. Okay, and the standard deviation is 5. The mean of the commissions is these are different things. 52.25 and the standard deviation is 773. Compare the variation of both. Okay, variation of these two. Okay, so I'm using these as my sample data values. Okay, I'm using these as a sample. So you know the, for the 3-month period, the mean number of sales is given 87. Therefore, I'm considering this problem as a sample. Okay. Therefore, X bar is 87, and the standard deviation S is given 5. Right. This is for the first two set of data set. Right. They are talking about the number of sales. So this is for a number of sales. Therefore, the coefficient of variation for the number of sales, right, is given by what's that? So you have to divide the sample standard deviation, which is 5 over X bar, which is 87. Okay, so find this number. Then the second one, the commissions, right? The commissions. For the commissions, X bar mean of the commission is 52.25, and the standard deviation for that variable commission is 773. For this particular variable, my coefficient of the variation is simply same formula I'm using, 773 divided by 52.25. Okay, so find this answer also. Okay, then compare which one is higher or which one is lower. So that means if you use the calculator, the first one is coefficient of variance of the first case is 5 over 87, which is point 0.06, right? 0.06. But here you got 773 divided by 5225, so which is 0.115. Okay. Therefore, the coefficient variance or coefficient of the variation of the second variable is higher than the first one, right? Therefore, the coefficient of variation in coefficients is higher than that of the number of cells. Okay, so they may ask you to compare which one is higher. Okay, that is there. So now next one is the range rule of thumb. This is just the approximation. You could approximate your sample standard deviation by looking at only the range, right? So what are they telling? They are telling that you could estimate, you could round up, you could guess your sample standard deviation if you know the range. Range means what? You know the range is given by h minus l, right? The highest value minus the lowest value of the data set. If you know this number, so you could estimate your sample standard deviation as a range over 4, right? So if you have more data set, then you will get to kind of concrete value for sample standard deviation. Okay, this is kind of approximation formula. Okay, so now let's move to the very, very important theorem in statistics. This is called the Chebyshev's theorem. Okay, theorem says what? The proportion of values from a data set that will fall within a k is just a number, real number. K is here a real number, any number. Okay, but it is a positive, so we consider as a positive, but not necessarily an integer, can be any positive real number. So the proportion of values from a data set that will fall within k standard deviations, k times the standard deviation, of the mean will be at least 1 minus 1k squared, where k is the number which is greater than 1. Okay, so we consider the number k which is greater than 1. What does mean by that? Suppose if x is your data value, given data value, then the variable you could call as this as a variable, right? So this theorem says that you could find the data values, right? Data values of between mu minus k sigma and the mu plus k times sigma. So I have just summarized that expression, right, in this. Okay, that means at least 1 minus 1 over k squared, right? If you, this is just a number. This number is of course less than 1 number, because they say that the k is bigger than 1, right? K is any number bigger than 1. That means this fraction is going to be smaller than 1, right? So if you multiply this by 100, then you will get the percentage, right? So what are they telling? They are telling that, right, at least 1 minus 1 over k squared, right, times 100 percentage of the entire data values, will be between mu minus k sigma and mu plus k sigma. Right? For example, suppose look at this. For example, suppose if k is 2, right? Suppose if k is 2, then what is 1 minus 1 over k squared? Could you find out this number? So you know k is 2, simply plugging 2 here, right? So this is 1 minus 1 over k is 2 now, 2 squared. That is 1 minus 2 squared is 4. This is 1 4. 1 minus 1 4 is 3 4, right? So 1 minus 1 over k squared is 3/4. Percentage wise, this is 3/4 means if you multiply by 100, you will get 75 percentage, right? Right. What does mean by that? That means 75 percentage of your entire data values will be between mu minus 2 sigma, k is now 2, right? Right. That means what? That means at least at least 75 percentage of your data values, right? Suppose if you are given 100 data values, 75 of them at least will be between this range. Which range? The mu minus k is now 2 for this example, right? Remember, these two guys, mu and the standard deviation comes from your data set. Suppose if you know mu and the sigma, then you could find, this much the data values which falls between mu minus 2 sigma and mu plus 2 sigma. This kind of theoretical things. So when do this problem, by applying, then you will understand a little bit. So let me explain, this example. Okay. So remember, once you know k, you are able to find that percentage. Okay. So you have to keep in mind this is actually the summary of the Chebyshev, right? This is the summary of Chebyshev's theorem. So you could remember this. Okay, right. So now look at this example. For example, in which you are given a variable, right? Variable 1, right? If you know the variable means 70, that means mu is 70. And if you know the standard deviation, I am considering this as population, right? So you could extend this theorem to the sample also. Only thing is you need to change these two notations. So I'm considering this as for the population. Okay. So for example, in which the variable 1 has a mean of 70 and the standard deviation is 1.5. So you know these two now, right? That means at least 75 percentage of the data values fall between 67 and 83. How these two numbers came? These two numbers came from my expression here, right? Remember, earlier we saw when k is 2, you will get 75 percentage, right? So that means in this example, if it is at least 75 percentage means, what do they mean? That means my k is here too, right? So if you plugging these all three values into the summarizing thing, whatever I gave you here, there. So because I know my k is 2 now, I'm simply plugging k2 in your summary. So that means you could find the data values, right? At least 75 percentage of your data values will fall in this range. Which range? Mu minus 2 sigma, right? To mu plus 2 sigma. But now you know mu and sigma for this particular example. So mu is 70 minus 2 times sigma is 1.5, right? Simply I'm plugging these two. Then your x should be bounded above by mu, which is 70 plus 2 times and 1.5. Take your calculator and simplify. 2 times 1.5 is 3. 70 minus 3 is 67, right? Then this side, 2 times 1.5 is 3. 70 plus 3 is 73. That means what? That means you will find at least 75 percentage of your data values will fall between 67 to 73. That's what these two numbers, says. So this all kind of things we apply to which okay. Okay, so now I have already given the answers. You just go through and try to understand. That's it. So this is not going to be in detail. This is just the summarizing of your theorem I already gave you. So you can take a note of this, the summary and keep. You could use that. Okay. So look at this example. The second one. The mean price of the house in certain neighborhood is given. So you know the mean 50,000, and the standard deviation, a little sigma is 10,000. Find the price range. Okay, they're asking us to find the range like this, like this. Okay, you need to find these two numbers now. Okay, which at least 75. So at least 75 means we know now k should be 2, right? Right. This number coming from where? This number coming from 1 minus 1 over k squared times 100 percentage. Right. You have to ask like this. In order to get 75 percentage, what is my k? Right? That means if k is 2, then you will get this. Okay, so first you need to find the k by reading this number, at least this number. Once you know the k, you have to use the range formula I gave you and plug in there. Okay, so my range formula, remember, is what? My range formula says the original formula I gave you. So I'm using that formula, the formula I gave you, the summary formula, so mu minus k sigma formula. So that means my the data value, this is my the data variable. In this problem, what is my x? In this example, my x is the price of the house, right? That is my data value. So x is here the price of the house. So now we need to find the range of the price of the house. That's our task. So you need to find these two numbers. We don't know, right? The summary says what? These two numbers are given by mu minus k sigma left side, and my right side value is mu plus k sigma. You know now for 75 percentage, Chebyshev says that for the 75 percentage, k should be 2, right? So you know k. You know mu and sigma. You see, k is 2, mu sigma. Simply plugging these three values into your the inequality, then you will get the bound ranges. Okay. So my mu is now, I'm simply plugging the value. So 50,000, k is 2 times sigma is 10,000. Then that is my lower bound, the smallest value. So this is my variable range is going to be upper bound, which is 50,000 plus 2 times 10,000, right? Now simplify these two and you will get the range. So 2 times 10,000 is 20,000, 50 minus 20 is 30,000. Okay, so this side is 20 plus 50 is 70,000. So therefore, the price range of the house should be 30,000 to 70,000, right? In another word, at least 75 percentage of the number of household, the price will be between 30,000 to 70,000. Okay, so we got those two numbers. So, okay, good. So I'm leaving this problem example 2 for you guys. So please work out this problem and see. Okay, that's it for this section, and I have included here some exercise problems, and please work on this and tell me how it goes.